Hey guys, today we're going to be talking about quadratics and different characteristics of the graphs of quadratics. And today we're going to focus on how to pull those characteristics out of a graph and out of an equation. So if we have, I'm going to start off, given a quadratic in this form, which should be somewhat familiar to us, f of x equals ax squared plus bx plus c, where a is obviously not 0, because otherwise the x squared would go away. It would no longer be a quadratic. We call this the standard form of a quadratic, and we're going to look into how we can pull information out of that when we have an equation. But right now we're going to focus on the graph. So the graph of a quadratic equation, if you have that x squared, it's going to resemble what we call the shape is going to be a parabola, and that's what this blue shape is here. Parabolas can open upward like this, and for quadratics, they also can open downward like this. And we're going to see what in the equation tells us that in a little bit. But that's what this blue part is called. It's called a parabola. That's the blue part of the graph. Another special characteristic, when you have a parabola, there's a line right in the middle that's called the axis of symmetry. The axis of symmetry. And this line here, it's a vertical line. In the axis of symmetry, the parabola is going to be a mirror image over that axis of symmetry. And what that kind of means is any point that you find that's like over here on the left side, that point is going to be the same distance away from the axis of symmetry as the other side. So everything mirrors over. They're both the same distance from that middle. So that's what the axis of symmetry is. That's that red line. And the axis of symmetry is always going to be x equals whatever the vertical line is. So if this was, I think in our example, x equals -2, the axis of symmetry is the line x equals -2. It's going to be a mirror image over that line. Now if you take the axis of symmetry will touch the parabola at exactly one point, and that point we call the vertex. So this is the vertex. This point right here where the axis of symmetry touches the parabola, and the vertex will always have the coordinate that's the same as the axis of symmetry. So for the axis of symmetry, it's x equals -2, so your x coordinate is -2, and then your y can be anything. And for this example that we have on here, it actually is -2 as well. But the x will always match up with the axis of symmetry. The y depends on how far up or down you are. Now if we're speaking about the vertex of the parabola, it can be broken into two categories, or one of two things really. It can either be a max value, or it can be a min value. So max is for maximum, min is for minimum. If you have a parabola that opens upward like this, and like we see over here, that means your vertex is going to be a min. It's the absolute lowest that you're going to be. So this vertex would be a min at 2, 2. If your parabola opens upward or opens downward like this, then you're going to have a max value. It would be the absolute highest you could be. So min is the lowest, max is the highest. And one of the ways that we can tell this, if we're given the quadratic in this form, if a is a positive number, it's going to open upward and we'll have a minimum. If a is a negative number, it'll open downward and we'll have a maximum. So that a is going to tell us, that leading coefficient will tell us if we open upward or downward, and if we open upward we have a min, if we open downward we have a max. Those will be your two possibilities. So the first thing we're going to do is pull all of these pieces of information out of different graphs, and then we'll see how we can find them in an equation. So let's go ahead and look at our first example. This is the one we have up on the slides. So we want to find the vertex, classify it as a min or a max. So looking at the parabola, we open upward, we clearly can see, so we're going to have a minimum value. There's an absolute lowest, and it's going to be at the vertex, which you might be able to find is right here. So at -1, 0. X is -1, y is 0. So that's our min value here. Put a little arrow. And that was our first step. The next step was find the line of symmetry, also called the axis of symmetry. Axis of symmetry will be a vertical line that goes through the vertex. So let's go ahead and go through the vertex. And it would be the line x equals -1. It's a vertical line here. And what's special about the axis of symmetry, I'll show us with our next one. Our next step is to find the y-intercept, which is this point right here. And if we know this is the y-intercept, it's 1 unit away from the axis of symmetry. So if you go 1 unit on the other side, that's going to be another point on the parabola. So you can use the symmetry, the axis of symmetry, to find missing points, to find output values. And our last question here was state the domain and range. So the domain is going to be a set of all numbers x such that x, well, if you think about the x values, how far left or right you go, we keep on going out as we go further up, and since we're going up infinitely, we'll go out infinitely as well, so any x value is possible, so x is just an element of the real numbers. And our range is going to be all values y such that y, we'll think of the possible values of y. You go up infinitely in both directions, but with the shape of the parabola, you go down and you get to a certain point where you hit the absolute lowest, because when you're here, you start to go up in the other direction. So y can be anything so long as it's greater than or equal to 0. It does touch 0, but it doesn't go anywhere below 0. So that's the absolute lowest, so you can be anything that's greater than or equal to 0. And that was our first example. Now our second, we'll move on to the next slide. We have this parabola here. So we'll go ahead and do the same thing. You can go ahead and try this one on your own if you want and check with what I have here. The vertex, what you'd point out as being right here. We open downward, so we have a max at, and just find the coordinates. X is 2, y is 3, so max at 2, 3. And there you go for your vertex. The axis of symmetry is going to be a vertical line that goes through the vertex. So it should look like this. And that would be x equals 2. That would be your equation for the axis of symmetry. And then we are looking for our y-intercept now. So our y-intercept, we should find, just by looking at the graph, it's right here at the point 0, 1. It's your y-intercept. -1. And if you want to explore into the symmetry, you're 2 units away from the axis of symmetry, so 2 units away would be another point on the parabola on the other side. That can be really useful when it comes to graphing. And that was our y-intercept. Our last thing we're looking for here is the domain and range. So domain, think of all the values x. You're going down infinitely, but you are getting wider as you go. So x could be anything that is a real number, because any number going left or right is possible. Think of the values of y that you could be. Well, y goes down infinitely, so all these numbers below are possible, but it gets to a certain point where it won't go any higher. That's the max value, and your y value there is 3. So you're not going to go above 3, and you could be anything below or equal to 3, so less than or equal to 3. That would be your range for this function. And just like that, that's how you pull information out of a graph. Just look for those special characteristics. Our next thing we're going to do is see how we can pull the information out of this equation, given standard form. So in standard form, well, one of the nice things, we'll start off with the c at the end. In standard form, that's your y-intercept, so that's nice and easy to pull out. The a, well, that's going to be the leading coefficient, and that's going to tell us if we open upward or if we open downward. So if we open upward or if we open downward. And how we tell that is by the sign. We open upward if a is greater than 0. We open downward, open downward if a is less than 0. So if a is positive, it's going to open upward. If a is negative, then it's going to open downward. And now our last thing is how to find the axis of symmetry. In this form, so if we're in standard form, the axis of symmetry is going to be given by, well, it's always going to be x equals, and it's going to be negative b, or the opposite of b, over 2a. If we plug in the opposite of b over 2a, that'll give us the equation for the axis of symmetry, which will help us find the vertex as well. And this should look kind of familiar. If you think of the quadratic formula, opposite of b plus or minus square root of b squared plus 4ac, all over 2a, it's kind of like you just took this part out to find the axis of symmetry, opposite of b over 2a. So if you know the quadratic formula, you're just taking away that radical and everything underneath to find your axis of symmetry. Okay, so let's do a couple of pulling these key pieces of information out of different equations. So we're going to go ahead and erase. Our first equation, and we have to be in standard form to do these. So y equals 2x squared plus 4x minus 3. And we want to pull out the axis of symmetry, classify the vertex as a min or a max, find the y-intercept, state the domain and range. So we'll pull out the easy thing first, y-intercept. Well, just because we're in this form, we should be able to see really quickly the y-intercept is 0, negative 3. Y-intercept's nice in standard form, it's really easy to find. Next, let's find the axis of symmetry. The axis of symmetry. To do this, we're going to use that little formula, opposite of b over 2a. And all we have to do is substitute in. Opposite of b is negative 4, 2a is 4, so the axis of symmetry is the line at x equals negative 1. So that vertical line is the axis of symmetry. And now we can use this to find our vertex. So let's do the vertex now. So we're going to use this to find the vertex, but first, let's look at the A. The A is positive, so that means we're going to open upward, which means we're going to have a minimum value. So we're going to have a min at, and we know it's going to have the same x as the axis of symmetry. We need to find the y, and how we do that is we go to our function, y equals 2, and we're just going to put negative 1 in for x. 2 times negative 1 squared plus 4 times negative 1 minus 3. So the y is equal to negative 1 squared is positive 1, so 2 minus 4 minus 3. So we should end up with y equals negative 5. So that means when x is negative 1, y is negative 5, and that's going to be a minimum value for us. Just like that, we have the min. I'm going to make some space here. So now let's try to find the domain and range. The domain, it's going to be all values of x such that x is an element of the real numbers. That'll be true for our parabolas. But the y is where we have to think a little bit here. If we open upward, that means there's an absolute minimum value that we're going to be. That minimum value is negative 5. So y can be anything that's greater than or equal to negative 5. Since this is the minimum, that's the lowest we could be, so we can be anything that's greater than that. So here's your domain and range. And just like that, we've pulled out all the characteristics that we've talked about so far. Alright, we'll try one more. If you're feeling okay, you can go ahead and practice these on your own. If you want to do another one, we'll do another one together. Our next one, we have f of x equals negative x squared plus 6x plus 4. So let's start with that y-intercept. Nice and easy to pull out when we're in standard form like this. The y-intercept is 0, 4, right there at the end. That's your plus c. So just like that, y-intercept is done. We can find the axis of symmetry. Axis of symmetry, we're going to stick with this little formula right here, negative b over 2a. So the opposite of b is negative 6. 2a, a is negative 1, so over negative 2. So our axis of symmetry should be a positive 3. And just like that, we have the axis of symmetry. Now if we're trying to find the vertex and trying to classify it, well, let's see. Our a is negative, which means we're going to open downward, which means we're going to have a max value. So we'll have a max at, we know x is going to be 3, we just need to figure out y. So to figure out y, you put in 3 for x. Be careful here. it's not the quantity negative x squared, it's the opposite of whatever x squared is. So you would write it like this. The opposite of 3 squared plus 6 times 3 is 18 plus 4. 3 squared is 9. The opposite of that is negative 9 plus 22. So y should equal 13. So our maximum value is 313. And now we can go ahead and do our domain and range, and then we'll be all done. So domain, again, it's going to be all values of x, such that x is a real number. And our range, well, let's think about what we have. We're opening downward, we have that max value. So y is going to be anything that is equal to or less than. If this is the max, you can be equal to or less than that. And since our max is 13, we'll have a 13 in there. And just like that, we are all done. So go ahead and try some of these on your own and have a nice day.